So welcome back to this video. So now let's solve the third question. So in my previous videos I solved this question and also this one. So now we are going to solve this one. To solve this one, we'll solve it using the same procedure. It's equation 3. Solve the discrete equation. So our equation is yk plus 2 minus 2 yk plus 1 minus 2y of k, which is equal to 0. You know our first step is to assume we solve it in this format of yk equal to a lambda of k. So we use this format to solve the discrete equations. So now let's see this equation, how is it working? So this is our function and this is our coefficient and value. This is lambda, and now we solved. Our first step is to solve a lambda, then second step is to solve our coefficient. Now this one, k, is the index. This is a variable, and this one is the coefficient. So we solve this equation in this form. So now let's start solving the equation. So we will solve it now. So let's substitute these values. We have a of lambda. We take our index to be equal to the value of k, which is, when there's form, will be k plus 2 minus 2a lambda. We take the index, which is k plus 1 minus another 2 lambda to the power k, which is equal to 0. So now we solved the first step. Let's go to our second step. Our second step, we use our well-known exponential rules, which is k and lambda minus k equal to 0. So let's factor out. Let's factor out. Our common factor is ak, a lambda to the power k. Therefore, I'm left with lambda squared minus 2 lambda minus 2. So now we say a lambda to the power k is not equal to 0, because if we say it is equal to 0, it means that our whole function will be 0. So now let's continue with our solving. We say minus 2 equals to 0. Therefore, now let's factor this out. We say our factors are, I can see we don't have the whole numbers factors here, but we can use quadratic equation if you want. You can use quadratic equations. So in quadratic equations, I found that lambda is equal to using quadratic equation, you will do it like minus b plus b minus 4ac. You will use this formula. So to simplify this, lambda, I got 1 plus the root of 3, and another lambda, I got 1 minus the root of 3. So now let's substitute back our lambdas. When we substitute back our lambdas, we will get our function as this is step 1, step 2, step 3, step 4. Now we're going to step 5. So we will substitute our function as a one plus the root of 3 plus b the root of 1 minus the root of 3. This is to the power k and to the power k also. So remember that this is our values that we found. So now this is the equation. We solved the equation. So now we have to conclude this. To conclude this, I will have to solve the value of a and solve the value of b. To solve these values, I will solve the value of a in my conclusion. I want to solve the value of a and the value of b. So to solve the value of a and solve the value of b, I will have to make an assumption that at where the value of k is equal to 0, my function is equal to 1. You can put any number here where my value of k for condition 2 is equal to, let's say, 1. Therefore, my value of k can be, let's say, 0. So now let's continue. So if my value of k it's 1, so I'll substitute 1, I'll substitute 0. If my value of k is 0, I'll substitute 0, meaning that I will have something like 1 plus the root of 3 to the power 0 plus b 1 minus the root of 3 the power 0 equals to 1. So when we come to the second function, when my value of k is equal to 1, I'll have this 1 plus the root of 3 to the power 1 b 1 minus 3 the power 1 equals to 0. Where now I have to solve the value of a and the value of b. So I have these equations, a plus b equals to 1. Let's call it equation 1. And I have this equation 1 plus the root of 3 b 1 minus the root of 3 b equal to 0. So equation 1 is equals to 1 since here. Therefore equation 2 is equals to 0. So now let's solve the value of A and the value of B. We are doing simultaneous equations from equation 1. A equal to 1 minus B. Therefore, I'll substitute, let's call it equation 3 into equation 2. So substituting equation 3 into equation 2, I will get one minus the root of 3b, which is equal to 0. Then when you continue solving this, 1 plus 3 minus 1 plus 3 plus 1 minus the root of 3b. When you continue solving, you will get your b as 3 plus the root of 3 over 6, and your a as 3 minus the root of 3 root 6. Subscribe and press the like button so that I can upload more videos.